Good day. Today I'll discuss all about differentiation formulas, how they are used, and what are the variables seen in the formulas. After that, I'll show you and give you an examples of each of the rule to further understand it. First, we have the power rule. The power rule is a quick tool for finding the derivative of a function. The power rule tells us that to raise a power, just multiply the exponents. The formula for the power rule is the derivative of x raised to the power of n is equals to nx raised to the power of n minus 1, where our n is constant and our x is variable. An example would be the derivative of 3x squared. To follow the formula, we are going to multiply our constant, which is the 2, our constant, to the coefficient of our variable, which is 3x. So it would be 2 times 3x raised to the power of 2 minus 1. The answer would be the derivative of 6x. Now let us move on to the constant rule. Constant rule states that the derivative of a function is 0. That is, since a constant function is a horizontal line, the slope or the rate of change of a constant function is 0. The formula for the constant rule would be differentiating with respect to x, the derivative of the constant c is equals to 0. One example would be f of x is equals to 3, where f prime would be equals to 0. To further elaborate this, we will be using the definition of derivatives, where we know that f prime x is equals to the limit as h approaches to 0 for f of x plus h minus f of x over h. So we will have limit as h approaches to 0 for 8 minus 8 over h. So 8 minus 8 would be 0. As we know that 0 over h, or 0 divided by h, would be 0. So we can conclude that the derivative of any constant would be 0. Next is the derivative of a multiple constant, or multiple rule. Constant multiple rule states that the derivative of a constant c multiplied by a function f is the same as a constant multiplied by the derivative. The constant multiple rule formula would be the derivative of a constant times a function is equals to the constant times the derivative of the function, where rc would be our constant and f of x would be, or f would be, our function. An example would be the derivative of 4x raised to the power of 6, where 4 will be multiplied to 6x raised to the power of 6 minus 1. Our answer would be 24x raised to the power of 5. We are now going to tackle about the sum rule. The sum rule states that the derivative of the sum of a function f and a function g is the same as the sum of the derivative of f and the derivative of g. The formula for the sum rule would be f of x plus g of x is equals to the derivative of f of x plus the derivative of g of x. An example would be the derivative of x cubed plus x raised to the power of 6 is equals to 3x squared plus 6x raised to the power of 5. Why? How did we get this? So, first, we'll get the derivative of x cubed, which is our f. So f prime is equals to 3 times x raised to the power of 3 minus 1. So the derivative of f would be 3x squared. Next is x raised to the power of 6. So g prime or the derivative of g would be equals to 6 times x raised to the power of 6 minus 1 would be 6x raised to the power of 5. Thus, we get 3x squared plus 6x raised to the power of 5. Now we will discuss about the product rule. The product rule tells us how to differentiate expressions that are the product of two other more basic expressions. Basically, you take the derivative of f multiplied by g and add f multiplied by the derivative of g. The formula for the product rule would be the derivative of f times g is equals to f prime g plus f g prime. One example would be the derivative of 2x minus 3 cubed times 2 plus x squared. First, we'll get the derivative of f, which is 2x minus 3x cubed. So the derivative of f would be 2 minus 9 squared. And the derivative of g would be 2x. Now we're going to follow the formula. So the derivative of f times g would be the derivative of f, which is 2 minus 9 squared, and g, which is 2 plus x squared plus f, which is 2x minus 3x cubed, and the derivative of g, which is 2x. Moving on, we will discuss about the quotient rule. The quotient rule is stated as a ratio of the quantity of the denominator times the derivative of the numerator function minus the numerator times the derivative of the denominator function to the square of the denominator function. So the formula for our quotient rule would be the derivative of f over g equals g f prime minus f g prime over g squared, where our f would always be the numerator and our g would be the denominator. So an example would be the derivative of 4x plus 2 over x squared plus 3. So the derivative of f over g would be, as we follow the formula, first g, so x squared plus 3. And our derivative of f, 4. Minus f, which is 4x plus 2. 4x plus 2 times the derivative of g, which is 2x, over g, which is x squared plus 3 raised to the power of 2. To simplify it, we will multiply 4 to x squared plus 3. So it would be 4x squared plus 12 and 2x to 4x plus 2, considering or with respect to the negative sign. So our answer would be negative 8x squared minus 4x. Now we will combine the like terms. 4x squared minus 8x squared would be 4x squared, and we will arrange the given. So our answer would be 4x squared minus 4x plus 12 all over x squared plus 3 raised to the power of 2. Now, let us end the discussion regarding the differentiation formulas. I hope you learned a lot. Thank you!